Alrighty, these are notes, section 3.6, and we're going to be solving multi-step inequalities. Multi-step inequalities. Now I've listed all the steps here. There are 8 steps that need to be followed, and you should read through these. Number 1, draw a line down through the inequality symbol. Number 2, make double sign changes. Number 3, simplify the right side. It means you need to maybe distribute or add like terms. Then simplify the left side by distributing and adding like terms. Get all the variable terms on one side. Then get the variable term alone. Finally, get the variable alone. And don't forget what you learned just yesterday. If you multiply or divide both sides by a negative, you must flip the inequality and make sure your variable's on the left. And finally, graph. Okay, I just read through them very quickly, but they're there for you to refer back to. Alright, let's try just maybe, I don't know, a couple examples. So down here, I'm actually going to do number 2. So if you focus in there on number 2. Alright, going through the steps. Draw your dotted line through the inequality. Make double sign changes. Distribute. And here we go. Negative 12 is greater than, now when I distribute, negative 2 times x, that gives me negative 2x plus negative 2 times 4, negative 8, plus 4 times x, 4x, plus 4 times negative 2, negative 8. Okay, on the right-hand side, well, the left-hand side, there's really not much, just a 12. So let's write our 12. Let's write our inequality symbol. Now on the right-hand side, we have some like terms. There's a negative 2x, which can be added with 4x. Remember, you can only add like terms. So negative 2x and 4x is 2x plus a negative 8 added to another negative 8. Negative 8 plus negative 8 is negative 16. Okay, now we unwrap this. You start like unpeeling the layers of an onion or unwrapping a present. So we'll add 16 to both sides. Hopefully you remember doing problems similar to this in the previous unit. 12 plus 16 is 28. Bring down your inequality symbol, bring down your 2x. A negative 16 and a positive 16 adds to 0, so I don't have to worry about it. Then I need to divide by 2 on both sides. 28 divided by 2 is 14, is greater than x. Okay, I would almost be done, but I'm not supposed to leave the x over here on the right. I need the x on the left-hand side. So I take this and totally reverse it. You just flip it right over. X is less than 14. You have to flip everything, including the symbol in the middle. Notice this was flipped over. Okay, now I can graph it on a number line. I'm looking for all the numbers less than 14. So 14, 15, 16, it gets higher as you go to the right. And then we count down to the left, and we're looking for numbers less than 14. So hollow around 14, because 14 doesn't work. It's not less than itself. And all the numbers less than are to the left. So all these numbers would be called solutions. They would work in the problem. All right, let's flip the page over. We'll try some on the back. Let's try number 4. So let's zoom in on number 4. All right, dotted line through the inequality symbol. Double sign change. Distribute. Okay, here we go. 5x plus negative 17 is less than or equal to. On the other side here, I'm going to distribute negative 3 times negative 4x is 12x plus Negative 3 times 8, negative 24. Now in this problem, you have x terms on the left-hand side and on the right-hand side, and that gave some of you some trouble in the previous unit. Take care of that right away. We don't want x's on opposite sides. We eventually want all the x's here on the left, so let's move this 12x. To move 12x, subtract 12x. And do that on both sides of the inequality. So we're trying to get all the x's on one side. Okay, 5x take away 12x is negative 7x. Bring down your negative 17. Bring down your symbol. These two turn out to be 0. 12x plus negative 12x. And then bring down your negative 24. Okay, now you can unwrap it. So I'm going to add 17 to both sides. That leaves me with negative 7x. A negative 17 and a positive 17 is 0. Bring down my symbol. And then negative 24 and positive 17 gives me negative 7. Divide by negative 7. Dividing both sides by a negative. We just learned about that yesterday. When you divide both sides by a negative, you have to flip this. You have to flip it. So I will get x is greater than or equal to 1. Alright, let's graph it. We're looking for all the values greater than 1. So 1 is in the middle. We're going higher to the right, counting down, going lower to the left. We want all the numbers that are greater than or equal to 1. Greater than or equal to, so you color it in. And the numbers greater than 1 would be going to the right. So you're going to color everything to the right. These are all the solutions that would fit in the problem. All right, let us try number 6. There's a little twist here on number 6. All right, I can make a double sign change. And I need to distribute here. Oops, dotted line. So negative 5x plus 36 is less than negative 5x plus 35, right? You distribute. Negative 5 times x, negative 5x. And then negative 5 times negative 30, negative 5 times negative 7 is 35. Okay, I have x's on both sides. You really have to take note and look for that. That's a problem. I don't want them on both sides. I usually want them on the left-hand side. So let's get rid of this negative 5x. Let's add 5x. Okay, what is negative 5x plus 5x? If you lost 5 and gained, that's nothing. That ends up being 0. I still have 36. Over here it's also 0. Negative 5 and positive 5 is 0. Bring down your 35. Okay, this is one of those weird ones. There's no variable. So that's weird. And what's even weirder is that negative 36 is not less than 35. So that is false. There's no variable and it's false. That means there is no solution. This problem cannot be solved. It's impossible. All right, number 7. There's a little twist on number 7 too. Here we go, double sign change, distribute, dotted line. All stuff we learned in the previous unit. 16 plus negative 2x is greater than or equal to, now distribute, you'll get negative 2x plus negative 2 times negative 5, 10. I have x's on the left and I have x's on the right. That's a problem. Let's get rid of these x's on the right. Let's add 2x. All right, that leaves me with 16. Whoops, I don't want that to be blue. I would like that to be red. 16. What's negative 2 plus 2? That's 0. Over on the other side, what's negative 2 plus 2? 0. Okay, so this is weird. There's no variable, so that's strange. But this time it's not really totally strange because 16 is bigger than 10. 16 is bigger than 10, so it's actually true, but there's no variable. So this is all real numbers. All real numbers. So we can graph them. What are we graphing? Everything. So the whole entire graph, both directions, gets colored. The whole graph gets colored. Every single number. You can put any number on here you want. 0, 1, 2, any number. You're coloring it all. Because no matter what number you pick, if you plug it into the original problem, it's going to work. Versus over here, no matter what you pick, it's not going to work. So notice we didn't graph anything. All right, we're almost done. Last problem. Tell whether the given number is a solution. Now there's 4 different problems or numbers to pick from. So here's what I do. I take this and I solve it. So here we go. 3x minus 5 is less than or equal to 4. Dotted line. Add 5 to both sides because I'm just unwrapping it. 3x is less than or equal to 9. Divide by 3. X is less than or equal to 3. Then I graph it. And it says, here it says less than or equal to 3. So color in the 3. Less than. And now I can go back and answer the question. The question was, tell whether it's a solution. Solutions are what's colored. So 5. Is 5 colored? No. So that means it's not a solution. Nope. 0. Would 0 would be here. Would that be colored? Yes, eventually 0 would be colored. So that means it's a solution. We color the things that work. Negative 1. Negative 1 would be down here somewhere. Would it eventually be colored? Yes, it would. That means it's a solution. And the last one, 4. Is 4 shaded? Is it colored? Nope. That means it's not a solution. All right, I hope these are helpful notes.